If you're looking to add speech-to-text functionality to your Expo React Native app, you might have come across solutions using the React Native Voice NPM package. If you intend to use Expo Go, this poses an issue because the React Native Voice package relies on native iOS and Android modules to transcribe speech into text. What we're instead going to implement today is an alternative method compatible with Expo Go that will use Google's speech-to-text API to transcribe audio recorded using the expo-av package. This will be a full-stack application written in TypeScript. We're going to build an Express.js server endpoint to handle our API calls to the speech-to-text API. Our front end will be an Expo React Native application that seamlessly transcribes our speech on both iOS and Android devices using the Expo Go app. Here's a quick demo of what the finished product is going to look like on both iOS and Android. Both of these physical devices are running the app on Expo Go. Hello, I'm testing the speech-to-text functionality on both iOS and Android for my video. The nice thing about this setup is that we can use one code base to deploy both mobile apps and web apps. We will also be setting up the speech-to-text functionality in a web environment, specifically both Safari and Google Chrome browsers. I'm going to go over all of the nuances and caveats that go into setting up cross-browser compatibilities. Alright, let's get started. You're going to want to have Node installed on your system. We're going to be using npm to manage our JavaScript dependencies. We're going to be using TypeScript throughout this video to maintain strict types. You can also have Git installed for version control. A local emulator for either iOS or Android devices will also be very helpful for developing the mobile app for Expo. Alright, so we're going to create a new directory. I'm going to call mine speech-to-text expo, cd into that directory that we just created, and open it up with the code utility tool using code dot in VS Code. So now that I have that directory open in VS Code, I can go ahead and get started by opening a new terminal, and we're going to create a new Express server right now. Okay, so the first file that we're going to create for our Express server is going to be the package.json file. So I'm going to initialize that by typing in the terminal npm init-y, and this will create a brand new package.json file. The next file that we need for our Express server is our index file. So we'll touch index.ts. This will create a file called index.ts. Alright, so now we have this package.json file. We also have an empty index.ts file, and so since ts dictates TypeScript, we are going to be using TypeScript for this video. The next file that we need is a tsconfig.json. I have some default configurations that I'm going to copy and paste into this file. Of course, you can create it from the command line using tsc-init. I like this configuration of mine. You can go ahead and copy it from the source code that I will leave in the description below. Now we can go ahead with installing some basic dependencies. We're going to go ahead and run npm i express. We're also going to download .env for handling our environment variables. And we can go ahead and get started filling out that Express server. So the first thing we're going to do is we're going to import Express from Express. We're also going to install these Express types. So we're just going to copy that types express installation command and copy and paste that into our terminal. Alright, so now we're going to set up a very basic Express server here. I do have Copilot installed as a VS Code extension, so you might see some auto suggestions. We are setting app as the invocation of the Express method. We're going to set up a handler on app.get the root path, response.send. We're going to say the speech-to-text API is up and running when someone visits that path on our server. Next, we're going to listen on a port that will be serving our server, and I'm going to initialize that port value as either the port environment variable, or we're going to say port 4000. So this will be the variable that I'm going to input here. So this will run app.listen on this port, and the callback will be, I'm just going to copy this, server is running on port, and it will say that port value right there. Okay, so now we have a very basic Express server. I'm going to go ahead and save that. Now to actually start this index command, we're going to need a start script. And for this, I'm going to, because this is a TypeScript folder, I'm going to be using a utility tool called tsnode. We're going to write tsnode index.ts. This will start our index.ts file. And first thing we need to do is we need to run npm install. This will be a dev dependency. So we're going to write -d tsnode We're going to go ahead and install that. We're also going to install TypeScript, and these will both be dev dependencies. And then if we write npm start, this will start up our server. Great, so we see that server is running on port 4000. All right, so far so good. So next we're going to import .env/config. This will be the setup for our environment variables in our server. So now that we have .env.config, we also want to add a .env file. This will store our environment variables. We also want a .getignore file. This file is very important because we don't want to check certain files into version control. We don't want node modules, and we don't want that .env file that we just added when we do use Git to track our file changes across our app. So now that this is all set up, we can go ahead and start setting up our handler for actually running the speech-to-text logic on our server. So this will be a post handler, which will be at the route /speech-to-text. We're going to go ahead and also run a callback here. We have our request and our response coming in on that callback. And so this callback will be handled in a modular fashion. We're going to create a brand new speech-to-text function. So we're going to create a new functions directory. And within that, we are going to place a speech-to-text.ts file. This will be a TypeScript file that will handle our business logic for converting speech to text. This will accept the request and the response as a parameter. The request type, of course, is coming from Express, and so is the response type. From Google's documentation, we can see that the speech-to-text API expects a config object and an audio URL. So that's what we are going to be expecting as parameters on the speech-to-text endpoint. All right, so let's start writing the speech-to-text function. We're going to export const speech-to-text. This will be an asynchronous function that accepts both the request and the response as parameters. We're going to also import the request and response types from Express. So we're going to write import request and response. And since this logic is handled inside of a post request, we are going to assume that there's some data coming back on the request body. So we're going to set the variable data to request.body, and we're going to pull out the audio URL from that data. We're going to say data. If it exists, we have the audio URL object on it. We're also going to have the audio config object on that data that's coming in on the request body. And if we don't have it, if we don't have the audio URL, we are going to go ahead and return early. We're going to say we're going to return the response with a status of 422. And this will say no audio URL was provided because there's no audio URL. And if we don't have an audio config, so let's say we do have the audio URL, but we don't have the config object, we're going to go ahead and return something similar. We're going to say response.status 422, no audio config was provided. All right, fantastic. So now at this point in the function, we are going to go ahead and handle the actual logic that will handle the audio conversion. We're going to wrap all of this inside of a try-catch block. In the catch, we're going to extract that error object. We're going to console error converting speech to text. We're going to return the contents of that error object. We're going to send a response back to the user at this point. We're going to say response.status 404. This will be an error status code, and we're going to send back that error, and we're going to go ahead and return the error as well. Now, within the try block, we are going to write the business logic for the speech-to-text conversion process using Google's REST API. All right, so we're going to be using this audio URL and the audio config that we've extracted from the body. Let's also set some middleware on Express. We're going to use app.useexpress.json to handle that request body on the post requests. And within the configurations on the express.json, we're going to set a limit of 50 megabytes because the audio URL strings tend to be a little lengthy. If you have, if you're recording a little bit of longer audio, and we want to have the server be able to handle that, we're going to import the speech-to-text function logic from our functions directory. and we can go ahead and start writing out the logic within the try block there. All right, so from Google's documentation, we can see that they provide a V1 speech recognition endpoint. So that's the endpoint that we're going to be utilizing within this try block. We're going to use the fetch API, and we're going to say await fetch from this endpoint. This will be the recognition endpoint. The second parameter to fetch will be an object. We will have the method of the fetch call. This method will be post. This will be a post request. As we saw from the docs, we'll also have a body. We'll go ahead and JSON stringify this object, which will contain our audio URL. So we'll say the audio content will be the audio URL string. We'll also be sending the config. This will be the audio config that we've extracted from the body of the request of the speech-to-text endpoint. Next, let's set some headers on the request. We're going to send over the header type of accept. We're going to say application JSON. We're going to send the content type header as application/JSON as well. And very important last header is going to be the Xgoog API key, which will be our API key for using the Google REST endpoint. Okay, so this will be within our env file. This will be process.env.google speech-to-text API key. This is very important. This will allow us to authenticate with Google. After this fetch call is done, we're going to say .then, and we're going to use the JSON method on the response to be able to extract that transcription and the result score, etc. Okay, so this will be set to our speech results, this entire await call from fetch, and we're going to return back, we're going to send back to the client response. Let's send the speech results. At this point, we are essentially done with the business logic for the speech-to-text app. The last thing we need to do is set up that Google API key for the Cloud Speech-to-Text API. So we're going to find that speech-to-text API from within Google Cloud. We're going to go ahead and enable it. I've already enabled it here. We can see some of the pricing here. For the Google Speech-to-Text API, the first 60 minutes of every month for the V1 version of this API is free. We're going to go ahead and click the Manage button, and we can see that to use this API, we need credentials. So we're going to go ahead and click the Credentials tab on the side there. The next thing we need to do is we need to set up an API key to use this endpoint. We're going to click Create Credentials. And we're going to click the API key button. We're going to create an API key. And this will be an API key that we store in our environment variable. So we see that API key has been created. We can go ahead and copy it using the copy button over here. And so we need to store this in our server. We're going to go back to VS Code. And we're going to go ahead and store it using that same environment variable that we expect in our server. Reminder that this should be in our .git ignore, so do not check that .env into version control. Okay. All right. So now we're done with our server setup. Now let's set up our client-side Expo app. We're going to run npx create expo app at latest. Our app is going to be named client. Well, my app will be named client. You can name yours whatever you want. This will create a client directory and will initialize a default expo app within that directory. So we're going to wait for that to finish installing. All right, so now our default Expo app has finished initializing within that client directory. We see it's populated with the default Expo setup there on the side. So the first step that we're going to do with our client side is we're going to cd into the client directory, and we see those files there. To get this Expo project started, we're going to run npx expo start. I have an iOS emulator running here on the side. This will be where we see our Expo project once it gets up and running. All right, so now we see that our Expo project has successfully started. We see the welcome page. We can see the breakdown of how the different pages work within our directory. We're using Expo router here on the side. I believe all the latest Expo configurations use Expo router. You can see here we have our tab screen, this explore page and whatnot. And this is quite a bit more advanced than what we need for this basic speech-to-text app that we're going to set up here. So I'm going to clean this up a little bit. We can see that the tabs are being referenced here, so we don't really need them for this video. So what I'm going to do is I'm going to pull this home screen out. I'm going to move index.ts into the root app directory. I'm going to remove the tabs directory entirely. We see we have an error there now. So what we're going to do is we're going to change that screen with parentheses tabs inside of it. We're going to change that to our index screen. This will be the home screen that we have right here. And we're essentially going to write all of the app logic within that index home screen. Okay, so our speech-to-text app is going to live within this file. All right, so now that we're all set up with our basic app, I'm going to remove some of this boilerplate code, and we're going to be starting from scratch here. So within this component, I'm going to return a view, and within this view, I'm going to write some text here. And we're going to see if we can get that rendering out on the emulator. So I'm going to say hello world, and we can see it's just out of view on the emulator itself. We see that hello world being rendered, so it is being rendered successfully. And I'm going to do a bit of cleanup here. And this will actually, we're going to put this inside a safe area view so that we can actually see what we are rendering out on the screen, and it's not obstructed by that little top part of the phone. Within there, we are going to include a scroll view so that we can actually scroll the content of the page. You can see that our view, our text element within the scroll view is a bit small. So I'm going to add another view within there. And now we can set up a bit of styling, make our app look a little bit nicer than it currently does, and add a bit of content as well. So we're going to add to our style sheet. We're going to start by adding a bit of styling to our main scroll view. This will be a main scroll container with a height of 100% and a width of 100% as well. The way we set styles in React Native is we set the style element using the style sheet to styles.whatever the class name is there. This will be called main.scroll container. We're going to add a bit of padding to that main scroll container as well. Next, we're going to change the text within the view here, within the scroll view, to, we're going to change it from hello world. We're going to say something more pertinent. We're going to say welcome to the speech to text app. Okay, so this will be the main header, just so you can see what that's looking like there. Next, we're going to set a style for our inner container within the scroll view for our view. This will be called the main inner container. This will have a style of, we're going to say a height of 100%. It will have an align items style of center. Everything in React Native has a display flex. We're going to say justify content center, align item center, and we're going to set that style as well on that view. We're going to say styles.main inner container. All right, and now we're going to set some styling on the text. We can see it's centered right now, but let's add some more styling on that text. We're going to say styles.title, and so we're going to add a title field within our style sheet. And we're going to add some styles for the text. We're going to add a font size of 35. We'll add some padding on that text, a padding of 5. Font weight, we'll say it's going to be bold. And we'll add a text align field of center. Margin bottom, we're going to say 20, and this will be our styling for the main title header of our app. All right, fantastic stuff. Now we're going to need a place for showing the actual transcription content, and this will be a view right under that title, and within there we're going to have some like placeholder text for now. I'm going to say your transcribed text will be shown here. Okay, this will be some placeholder text that we have here. All right, looking pretty good. I think we'll also need to add some styling for that transcription container. Let's say style is assigned to styles.transcription container, and we're going to set some styles there in our style sheet. I'm going to copy that field name. We're going to say the transcription container has the styles. We'll do something like, we'll add a background color, which will be like a grayish, like a light grayish, something like RGB, we'll say like 220. will be like a light gray, something like that. We'll see it in the hot reload. Yeah, something like that. The width will be, we'll say a width of 100%. This will stretch most of the screen there. The height will be, we'll set it to a static height of 300. The padding will be 20 for that text to have a bit of padding. And we'll add a margin bottom of 20 and a border radius of 5, make it look a little bit fancy. We'll say flex direction is row. In general, in React Native, all the flex direction is column, so we'll set it explicitly to row. Align items flex start to the beginning of the container. Justify content also flex start to the beginning of the container. So that looks pretty good to me. That will be our transcription text container, right? I think we'll also add, a button that will let us actually record our audio, record our voice. So for this, we'll use the touchable opacity component from React Native. Now, I really like the Expo Vector icons library for icons. So I'm going to look up a microphone icon. I like this font awesome one. I'm going to use this for our microphone button. All right, so within our code, we're going to import font awesome from Expo Vector icons. We're going to use that font awesome microphone component. The size will be, let's say something like 40. I think that looks good. All right, so next we can add some styles to that microphone button. We're going to set the style to styles.microphone button, and we are going to add this to our style sheet. The microphone button, and we'll add some styles. We'll add a background color. Let's say the background of the microphone button will be red. And we'll add a width of 75, a height of 75 as well. This will just be a round button, followed with margin top of 100, a border radius of 50, and we'll also add an align items style of center and justify content center to get that button centered. All right, I don't really like the black microphone. I think we'll do a color of white. I think that looks pretty good. Next, we can add some basic state to the app. We're going to add a state for our transcribed speech. We're going to say set transcribed speech. We'll set this to a default value of an empty string. This will be the transcribed speech when we receive it from our server endpoint, right after we transcribe our audio. The next state we want to add is an is recording state. We'll say is recording, set is recording. This will be a Boolean. Use state default of false. Next, we'll add a is transcribing, set is transcribing state, default value of false. All right, now to make our app a bit more dynamic, let's start using our state from our app that we've set here. I'm going to wrap this in parentheses. I'm going to set this to a string value. We're going to set the transcribed speech here. If it doesn't exist, we'll add the placeholder text. It'll say your transcribed text will be shown here. If we don't have it, if we do have it, we can show it. I think within the transcription container, let's set some styles on that transcribed text. We'll go back to our style sheet. Transcribed text will have the styles. I'm going to add a comma here. Transcribed text will have the styles of, we'll say, a font size of around 20, a padding of 5, and a color. This will be a black color in hex. Text align will be aligned to the left, and we'll add a width of 100% to the transcribed text, and I think that should look good. Next, let's add some conditional styling on this transcribed text component. On the styles here, we'll add an ellipsis on the styles.transcribed text. Next, we'll add the color style. If we do have transcribed speech, the text will be black. Otherwise, it will be sort of a darkish grayish color. That will be our color on the text component here for transcribed text. Next, we're going to set up a ternary condition here based on the is transcribing state. So if it's transcribing for now, we'll just put some React fragments here. If it's not transcribing, let's move this whole text block into the false condition. We'll save that, see what that looks like. If it is transcribing, Actually, instead of the React fragments, we're going to import the activity indicator from React Native, which is really nice. The size, we'll make it a small little activity indicator. It's going to be color, it'll be #000, which is black. For now, let's just test out what that looks like. We'll set it to true, and we see that activity indicator spinning there. So that looks pretty good to me. All right, so now we're going to do something very similar for the microphone button. We are going to use the isRecordingState. Right now we just have the font awesome component there, but we're going to make it a little bit more dynamic by using that isRecordingState that we've set up earlier. So the first thing we're going to do is we're going to set up these brackets here, is recording. We'll set up a ternary. If it's true, we'll set up some fragments. If it's not recording, we have that font awesome icon ready to go. Again, we're going to be using that activity indicator from React Native. This will be a loading spinner. That'll be the exact same component as before. We'll set up the color as white in this instance. Just to test it out, we'll set this to true, and we see that spinner indicator there. All right, so that looks good also to me. All right, the next thing we're going to do is we're going to set up some conditional styles on the isRecordingState. So on that style prop on touchable opacity, we're going to set that as the that's set as the object as styles.microphoneButton. We're going to add an ellipsis on the styles.microphoneButton object, and we're going to add some conditional styling on the opacity in particular. So if you have your isRecordingState, right? So if it is recording, or we'll say if it is transcribing, we'll have a ternary expression there. We'll have 50% opacity. Otherwise, we'll have full opacity, okay? Also, I think another field we can set is the disabled field. So if it is recording or it is transcribing, we'll just disable that entire button. And we'll see what that looks like on our emulator, see if that looks good. If it is, we'll set that to true for now, just to test out what those styles look like, if the opacity looks good, and if the button looks disabled. So that looks pretty good to me. All right, so now we're going to add two methods on the touchable opacity. We're going to add an onPressIn method. So when you press down on the microphone button, and we're also going to add an onPressOut method, which is when you take your finger off of the button. And we're going to handle both of these instances, both of these events with a function. First, we're going to add the start recording function. We're also going to add the stop recording function. Okay, so what do we expect to happen when the button is pressed initially with your thumb, right? So the first thing we want to do is we want to set the isRecordingState to true, and if we stop recording, we want to set the isRecordingState to false, right? We also want to set the isTranscribingState to true, because at this point we're expecting that the audio recording is finished, right? So we want the server to handle the transcription of the audio at this time, right? So once we've set the isRecordingState to true, we want to record some speech, right? And once we stop recording, we want to transcribe the recorded speech, right? The audio. We're essentially going to be sending this over to the server at this point, which will handle the transcription and send that data back to the client side, right? So the both of these methods are actually going to be asynchronous, because we're going to be expecting some response to the server, right? So we're going to be sending some payload, and we're going to be sending that to the server. And then once we're done with the recording, we can set transcribing to false. All right, now we're going to move on to using Expo-av package. We're going to import the audio object from Expo-av. We don't have Expo-av installed, so we're going to follow their installation steps from their docs. We're going to have npx expo install Expo-av. We're going to run this command in the terminal. So what I'm going to do here is I'm going to open up a brand new terminal, and I'm going to cd into the client directory. I'm going to run npx expo install Expo-av. I'm going to wait for that to complete. All right, and now per the documentation of Expo-av, we're going to set some microphone permissions in the app.json file that we have in our client. So we're going to copy and paste that Expo-av microphone permission into the plugin section, and we should be all set up for microphone permissions. The next thing we want to do is we want to set an audio recording ref. This is going to be how we interact with the audio object. This will be set to use ref, and within there we'll have the new audio.recording. Now let's create a brand new directory in the client directory called functions. And in here, we're going to create two files. The first file will be called recordspeech.tsx. And we're going to create another file called transcribespeech.tsx. And both of these will handle the business logic for how we record speech and how we transcribe speech. Export const record speech. And this will be a function that obviously records our speech using the expo-av module. I'm going to wrap all of this logic in a try-catch block. In our catch block, we have the error that we receive. If we do receive an error, we're going to go ahead and console out failed to start recording. This will be a console error. And we can also go ahead and show that actual error that we get back. And we'll also return out of the function at this point. For our try block, we are going to await audio. We're going to set some configs on the audio object. Because we're using await, this will be an asynchronous function. So we're going to have async await here. We will take a look at some methods on the audio object that we're importing from Expo-av. So we just copy pasted that import audio from Expo-av. We are going to set the audio mode async on that audio object. We'll set allows recording iOS to true, plays in silent mode iOS to true. These two configs are important, particularly for iOS recording. We're going to be passing in the audio recording ref that we created earlier into this function. So I'm going to copy that type on over, and we'll have the parameter of the audio recording ref. This will be the mutable ref object of audio recording as its value. I'm going to import the mutable ref object from React. And now we'll set the done recording variable to await audio recording ref. We're going to pull that from the current value, and it will have an is done recording Boolean value. Right? So if it is done recording, we'll have the audio recording ref.current, audio recording, not audio recordings. If it is done recording, we're going to set that audio recording ref.current value to a new audio recording. This is a little caveat of using the, I'm going to make this a one-liner. This is a little caveat of using that audio recording object because you can't reuse it after you're done recording. If you want to make a new recording, you have to set the old value to a brand new audio recording object. Just a little quirk there that I've noticed when working with this Expo-av library. Next, we are going to check the permission response. We're going to await that audio recording permissions async. This will trigger a permissions pop-up for the user if we receive a value for the status on that response of granted. Then we will move on with some logic there. Else, if we didn't receive a permission response status of granted, then we'll console error permission to record audio is required. Okay, and we are going to go ahead and also return out of the function at this point, right? So if we didn't receive a permission response of granted. The next thing we'll want to do is we'll want to check on the status of the recording. So we're going to set the recording status variable to await recording ref.current. We're going to grab the current value from the ref, and we're going to check the get status async method to get the recording's status. And from this recording status, we will basically determine whether or not we can even start the recording, right? So we might not even have this ref, so I'm going to set some existence checks there. And if we do have that recording status object, we are also going to check, well, actually we'll do a negative check, right? So if we aren't able to record, if recording status .can record, if that value is a falsy value, right? If we aren't able to record, then we'll have to do some preparations for that recording object. If we are able to record, then we'll just move on to just starting the recording. Await audio recording ref.current.start async, right? So that will start the recording process. But if we aren't able to record yet, there'll have to be some basic configurations that we'll have to set up for the recording object first. All right, so we're going to write await audio recording ref.current dot prepare to record async. This will prepare the recording for us. We're going to pass an object. These will be the recording options. We'll pass that in a sec, but first we'll say dot then. When this process is finished, we're going to console log prepared recording instance, and we are going to save that. And then we will also add a dot catch. We will catch any errors that might come up. We're going to go ahead and console error those. If this process fails, we'll say failed to prepare recording instance, and we'll show that error there. Now we can go back to setting the recording options to prepare to record async. We're going to set the const recording options right now to an empty hash. This next part is a little bit tricky. There are only so many audio encodings that both the Expo-av module and the Google Speech-to-Text API both support. For Android and iOS, one platform might support an audio encoding that the other one doesn't, so each one needs its own setup. Furthermore, not only does the audio encoding format have to match, but so does the sample rate, the means of encoding, and the number of channels. All of these have to match, so it's important to be careful about how you set these recording options. For the purposes of this app, we're going to be using AMR encoding for Android and Wave encoding for iOS. Back to the code, we have a default audio high quality preset, which is on the audio.recordingOptions presets.high quality object. We'll go ahead and copy this over into the recording options. We are also going to add separate recording options for Android and iOS, like we spoke about earlier. First, we are going to set an extension for iOS, which will be .wave. The audio quality will be using this audio object. We'll say audio.iOS audio quality.high. The sample rate will be 44,100 hertz. The number of channels will be just one channel. And the bit rate will be 128,000 or 128 kilobits per second. Next, we'll set some more options. We're going to set the linear PCM bit depth to 16. We're going to set the linear PCM is big endian to false, and linear PCM is float to false as well. Moving on to the Android options, we're going to set the extension to .amr as we discussed previously. We are going to set the output format to audio.android output format, and we're going to say .amr_wb. The audio encoder for Android will be audio.android audio encoder, also .amr_wb. The sample rate will be 16,000. The number of channels will be 1, and the bit rate will also be 128 kilobits per second or 128,000. Okay, so this is our setup for both our Android and iOS recording options, and those are being passed into the prepare to record async method. All right, now that the record speech function is essentially finished, we can go ahead and go back to our main home screen and fill out this start recording function. We'll say await record speech. This is a modular function that we've just created, and we'll pass in that audio recording ref. So start recording is ready to go. Now that we're done with the recording speech logic, let's move over to the transcribe speech function. And we're going to write export const transcribe speech. This will be a new async function that will handle the transcription process of our audio recorded with the record speech function. So I'm going to copy over the audio recording ref. We'll have the same parameter. We're going to import the mutable ref object from React. We're also going to import this audio object. I'm just going to copy all these imports. We're going to save that here. Now within this transcribe speech function, I'm going to write await audio.set audio mode async. We're going to turn off this allows recording iOS setting. We're going to turn off this plays in silent mode iOS setting as well. So we don't need to record iOS anymore. We don't need to have that playing in silent mode. So that is turned off at this point. Next, we want to check if the recording is prepared. So we have the audio recording ref.current. We're accessing the current object on that audio recording ref. It has a setting called _can record. So if it is prepared, if the recording is prepared, Then we'll have some logic, else if it's not prepared, we'll error out. We'll have a console error, recording must be prepared prior to unloading. Okay, so before we're actually able to pull out that audio URL, we need to make sure that recording is prepared. So at this point, if it's not prepared, then we'll return undefined. If it is prepared, then we can go ahead and pull out that data from the audio recording ref. So we'll say await audio recording ref.current.stop and unload async. This is important. It stops the recording and deallocates the recorder from memory. So at this point, we can pull out the audio URL from that recording. So we're going to set the recording URI variable to audio recording ref.current.get URI or empty string. Next, we're going to grab the base64 URI by using a package that comes from Expo file system. We're actually going to use the file system to read that data over from the recording URI. So we're going to go ahead and import asterisk as file system from Expo file expo-file-system. And this comes default from the Expo React Native package, so we don't need to do any extra imports at this point. We're just going to go ahead and use that file system package. We're going to say base64 URI equals await file system dot read as string async. We're going to read the data over from that recording URI. This will be a local path within our phone. We can read that data from the recording URI. We'll set the encoding as filesystem.encodingtype.base64. So it is base64 encoded, and then we can send this base64 encoded URI over to the Google API. So if we do have that recording URI and we do have that base64 encoded URI, then we can go ahead and make a transcription request to our server endpoint that we've set up earlier, our Node.js Express endpoint. So if we do have that recording URI and that base64 URI, then we can go ahead and make that request. If we don't have the recording URI or the base64 URI, we can go ahead and error out. We'll say console error, something went wrong while unloading the recording essentially. So we don't have any data coming back from that recording object. And we'll go ahead and return undefined at this point. We aren't able to transcribe the speech. If we do have the recording URI and the base64 URI, we can go ahead and make a fetch call. We'll say await fetch from, this will be our server endpoint. For now, this will be a placeholder. Our method will be a post request. We will set up some headers. Our headers will be, the first header will be a content type of application JSON. I think that'll actually do for now. The body, we will JSON stringify a payload with the audio URL, which will be set to the base64 URI. And we'll send over a config object, which we will create right now. We'll set a variable of const audio config to an object, the encoding field of which will be conditional based on the platform of the device that we're using. So if we're using platform OS is iOS, it'll be linear 16. Otherwise, it will be AMR_WB. We'll set the sample rate hertz field to, it will also be conditional based on the device. If it's iOS, it'll be 44,100. Otherwise, it will be 16,000. All right. So that's just based on the conditions that we set when we were recording the actual audio itself. The language code will be en-us. This will be the English language code. Okay, so that will be our audio config that we will be sending over in this fetch request to our server endpoint. The URL of the server endpoint itself, we're going to set the server URL to some empty string for now, but our actual endpoint itself will be based on whatever that root server URL is, /speech-to text, right? So that's how we set up that endpoint for our post request. The actual origin for the server, I'm going to set up my way. You can set it up however you want. I'm going to conditionally set it based on the operating system. If our operating system is Android, I'm going to set it to this default 10.0.2.2 IP address. If it's not Android, and if it's a physical device, which right now I'm going to import this Expo device library. So I'm going to go ahead and import asterisk as device from expo-device, and because I don't have this module installed, I'm going to go ahead and go into my terminal and copy paste in npx expo install expo device. So once that installs, I have the device ready to go, and I can see if the operating system is running on a physical device. If the app is not running on an Android device and the device is a physical device, then we are going to use the local dev IP environment variable. If it's not there, we'll just default to localhost. That way we can provide a static IP for use on our local phone. Otherwise, if none of these match, then we'll set it to localhost. So that's our server URL for now for API fetching purposes, for sending that recording URI, that base64 URI over to the server, to the post speech to text endpoint. Actually, I'm going to make some minor adjustments. This will be our root origin, right? And the actual full server URL will take into account that root origin. We'll set it to http://root origin:4000. So that will be our server endpoint for the server URL. If you're in production, you can set this server URL to whatever your production endpoint is for your server. For now, that while we're testing in development mode, this will be our server URL. So once we make that fetch call, we'll have some sort of server response. We'll say .then, we'll take that response and use the JSON method on it so we can parse the response. If we get some sort of error, we'll catch that error and console.error it out. When this server response resolves, we can then take a look at the response. If we can expect the server response to look a certain way, then we can run some additional logic. We'll take a look at the results. If the server response returns a results object, we can do something with those results. Otherwise, we'll return an empty array. So if we do have results, well, let's start if we don't have results, right? If we don't have results, we'll say console error, no transcript found, right? If no results come back, we can just return undefined because we didn't get back a transcript for the audio that we sent. If we do get results, we can go ahead and set the transcript variable to the results, the first index in the results. We'll say .alternatives, first index in the alternatives array, .transcript. This will be the text transcript for the audio that we sent. If there isn't a transcript, if for some reason at any point in that transcript object, if we don't receive a transcript, we'll say console error, no transcript found, and we'll return undefined. Otherwise, we can go ahead and return the text of that transcript. All right, and at this point we are pretty much done with the transcribe speech function, so we can go back to index.tsx and we can go ahead and implement it within our stop recording function when we take our finger off of the recording button. So we're going to add a try catch here in the stop recording async function. If an error is caught, we will say console error. The error will error it out. Otherwise, we are going to try to get that speech transcript. So we'll set the speech transcript variable to await transcribed speech. The function is called transcribe speech. We'll import it here, and we'll pass in that audio recording ref as a parameter. And if we do get that speech transcript back, we'll go ahead and set the transcribe speech to the speech transcript. If we don't have the transcript, we'll set an empty string. Let's also add a finally block to our try catch block. We'll set is transcribing false when everything is finished, because the transcription process is finished at this point. Alright, so now our start recording handler, our stop recording handler, both of these handlers are finished, so we are just left with setting them on the onPress and onPressOut methods of the microphone button, and we are finished with the recording functionality. Alright, let's do a quick demo of the functionality. I want to log some of the results out just to show you what that looks like when we get results back from the Google API. So we're going to go ahead and console log. We'll log it as an object, the speech results themselves, right? So when they come back. So if I restart my server, hello, this is another test of the recorder. And we get some speech results back there. We see the results, the total build time, the request ID using legacy models is true, and we see the speech text in the app, the result of that transcript. We can also grab the results from that results response, and then we can try it again. Hello, testing, testing, hello. We can see we've drilled a bit into the results. We see the alternatives array, And given that alternatives array, we can now extrapolate a bit of data. If we grab the first index, let's say, if we then look into the alternatives, we'll say first index of that, and we restart the server and try it one more time. Let's run npm start and try hello, one more test, another test. We can see the transcript value and the confidence score on those results. All right, so we're almost done here. I'm going to add some final tweaks. We have our expo-env-d-ts, the definition file for our environment variables. On Expo, environment variables are done using the expo_public prefix. So if we use expo_public, we have the environment variable set as local dev IP. Let's change that over to expo public, local dev IP, or localhost. You can set your static IP address there. So if we are using Android, let's change this up a bit. If we're on a physical device, we will use this static IP if it's there. If it's not a physical device, we'll use that 10.0.2.2 IP address. And if we're on iOS, if we have a physical device, we'll use that static IP address as well. So that's where we will actually be setting our environment variables, and you don't want to check that into version control either. And one more thing that I'm going to be adding is I'm going to add a background color of white to the main scroll container. All right. Now that we're finished with the main iOS and Android functionality, let's move on to the web side of things. For this, we will be using the webm_opus encoding for the Google speech-to-text API. On Safari actually has a little caveat that doesn't support the codec opus, so we will be using the audio MP4 encoding, which is more of a general purpose encoding. So we will add a web configuration to our recording options. We'll add a MIME type. We'll take a look at the platform operating system that we're running on. We'll make sure that we're running on web. And if we are running on web, we'll also take a look at the navigator. So we'll have that window object. So we'll say window.navigator.userAgent includes Safari. So we'll make sure if we're running in a Safari browser that we're using the right MIME type. So for this one, like I said before, we will be using the audio/MP4 MIME type. Otherwise, we are going to use audio/webm. And for this, we can add a semicolon and add codecs equals opus. So that's how we will be configuring the MIME type. Let's also set the bits per second, which will be 128,000 or 128 kilobits per second. Okay, so that is our configuration for web for our recording options. So we are done here. Let's also modify the audio config that we'll be sending to the Google speech-to-text API. So we have also added a web configuration. So our encoding, we have a setting for platform OS equals Android. Let's also add one if our operating system is web. If it's web, as we discussed earlier, the encoding will be webm_opus. All right. Otherwise, we will assume we are in iOS and we'll send linear 16. And let's also add another configuration to our sample rate hertz. So we have platform operating system is Android. It'll be 16,000. Otherwise, let's also add a platform operating system is web. And for that setting, let's add 48,000. Okay. So now we're finished with the modifications for our audio config. Let's move on. Now on web, there is yet another caveat, as I'm sure you've noticed there are a few of them, that comes about when we are actually reading the data that is in that recording URI. So on mobile devices, on iOS and Android, Expo very conveniently provides the file system API. And unfortunately, that file system API is not accessible within the browser environment. So for this, we'll need to implement some sort of custom logic to actually pull that data out of where that recording is actually stored from that recording URI. So for this one, we will set up logic for the operating system of web. So we're going to go ahead and actually copy this. So if we're not in web, we will use this base URI file system read a string async logic. And if we are in web, we will handle it using some other logic to actually set that base 64 URI. So we'll need to read that data and encode it to base64. Every browser has the fetch API. We'll use wait fetch to fetch the data from that recording URI. We'll say .then, we'll grab the response and use the .blob method to return the data from the recording URI as a blob. So once we have that blob, we see that type as blob, we can then extract the base64 from that blob. So what we will do is we'll set the found base64 to some data. First, we will need to actually create that blob to base64 logic. So for this, let's create a brand new function. We're going to call this read blob as base64.ts, and we will create that function. We'll say export const read blob as base64. This will be an async function that takes a blob as a parameter. Next, we will return a new promise, which we'll take our resolve and reject. And within this function, we will set the variable of reader to a new file reader. That's how we're going to read the blob, and we'll pull the data out of it. We'll say reader.read as data URL blob, and we'll also set a method of onload, so reader.onload. And we'll set this function to resolve reader.result to pull the data out of that reader. And if there's an error, we'll set the reject error. Okay, so this will be our read blob as base64 function that we are then going to use to actually read the blob data that we fetch from that recording URI, and we'll pull the base64 string out of that. So to actually use this function that we've created, we're going to set the found base64 variable to await read blob as base64, and we'll set that blob that we received from the recording URI as a parameter. This will return a base64 string, which will look something like data audio /wave semicolon base64, and we're going to have some data there at the very end. All of this is just an example, by the way, of what that base64 encoded data string is going to look like. So we're just going to pull the data out. That's what our audio config is for. Once we send that data over to Google's API, we're going to set the removed prefix base64 variable to found base64, except we're going to split on the base64 comma portion to isolate the data portion of the encoded base64 URI, and we are going to pull the string at index 1. Okay, so that will be the second element at index 1, and we'll go ahead and set the base64 URI to that variable. Alright, so now that we've set up transcribe speech on the website of things, let's go back to that home screen that we've set up in index.tsx, and we are going to implement a way for us to set permissions on the web. Yes, Expo-av has the request permissions async method on the audio object, but for the web, we're going to want a bit more granularity as far as getting microphone permissions and toggling them on and off when the app is not in focus. Of course, you don't necessarily need to set it up this way, but if you don't want the microphone to constantly be on, even when your app is not in the current focus tab, then this is going to be the way to go. So what we're going to do is we're going to create a brand new hook. We're going to go over to the hooks directory and create a brand new file called usewebfocus.ts, and here we will determine whether or not the current tab is the focused one. So we'll set the const usewebfocus to a function. We'll export default use web focus, this brand new hook that we're going to be creating. Let's start off by setting a basic focus state. We'll set a const focus, set focus to use state. The initial value of this focus state will depend on if we are on web. If the operating system is web, then we'll check the document.hasFocus method. Otherwise, we'll say false because we are not on the web, so it will not be in focus. We don't need this hook, and we'll return this focus state at the end of the hook. We will set up also a use effect within this hook, And within this use effect, we are going to be looking at a couple of things. We're going to add an event listener on the window object on the focus event. We'll have an onFocus method. We'll also add a blur event, and we'll have an onBlur function. And so we are listening on the focus and on the blur event. So on focus, we'll set the focus to true, so the tab is focused. And on blur, we'll set the focus to false. Okay, this will be on mounts. And then when we unmount, we'll go ahead and remove both of those listeners off of the focus and the blur. And we'll also add conditionals on the window object because it might not be available for whatever reason. But okay, this will be the logic behind the use web focus hook that we've created. This is some custom logic, and we will use this logic in the index.tsx component. All right, so now coming back to our home screen, the first thing we're going to do is we are going to set the isWebFocused variable to the useWebFocus hook, to the results of the useWebFocus hook. And now that we have whether or not the current tab is focused thanks to that hook, we can actually run a use effect that will depend on that variable. So we'll create a use effect, and in the dependency array, we'll add the isWebFocused variable. So within this use effect, if the current tab is focused, right? If is web focused, then we'll run some logic. Otherwise, we'll run some additional logic. So if it's not focused, right? Now, for the actual microphone permissions on the web, we're going to want to store those in a ref. So we're going to set the web audio permissions ref to use ref, and we'll set that to a null value for now. So we'll say if is web focused, right? Within that use effect, we are going to get the microphone access that will be used by the browser, right? So we'll set a function, we'll say get mic access equals some async function, and we'll go ahead and invoke that function that we'll be writing. So we'll say const permissions is assigned to await, we'll say navigator dot media devices dot get user media, and within that we'll set a parameter of audio true. This method will allow us to get the microphone permissions for that tab. This method is very important. The reason we're running this get user media query to set an active microphone audio track within a use effect instead of using an on-click handler, for example, is because different browsers handle this particular method in different ways, which means its behavior and performance aren't always consistent. This might take a few microseconds in Chrome, for example, but could take up to 4 or 5 seconds in Safari, which will lead to a subpar user experience. If you have the permissions ready to go off the bat when the app loads up, or at least the page where you want the speech-to-text functionality, that experience is much smoother. So what we're also going to do is we're going to set the web audio permissions ref, the current value, to the permissions that we get back from that await call. The type of that await call is a media stream. So within the use ref, since we're using TypeScript, we're going to set it to actually media stream or null. Now, that is what is happening when the browser is focused. So we will have that media stream available on the current value of the web audio permissions ref. If we don't have any current value on that web audio permissions ref, then we'll go ahead and get mic access. And if we don't have access, it'll trigger that little pop-up. If the current tab isn't focused, and if, let's say, we already have a value on that current web audio permissions ref, then we're going to get the tracks on that media stream. And for each of those tracks, we're going to go ahead and stop them. Those are going to be our audio tracks, and we're going to go ahead and stop them. They will not be active anymore, and we'll go ahead and set the current value on that web audio permissions ref to null. So there won't be any microphone access anymore on the current tab, and we'll be able to toggle it on and off just by focusing and unfocusing the current tab. Going back to the record speech function, we don't need this audio request permissions async logic, so we'll add another argument. We'll call it already received permission response. So if we have already received this permission response on web, then we'll avoid this await audio request permissions async invocation. And if we've already received the permission or the permission response is granted, we can go ahead and move forward with the record speech functionality. So I'm actually going to make this a one-liner. If platform OS is not equal to web, then we will be using the request permissions async method. And now that we've set up that third parameter on record speech, let's add it in. And here we will add it based on the web audio permissions ref.current. This will be a Boolean value that we will pass into the record speech function, whether or not we have those permissions from the web audio. All right, so now we're basically done with the web functionality side of things. I'm going to add some final tweaks. If the recording can't record in this section, just as a fail-safe, we'll set the audio recording ref.current to a new audio recording, a new object, just in case we can't record. And let's also set here inside the data URL at the base64 URI, we'll also set a new audio recording there when after we are done pulling out the recording URI and pulling out the data from that, just so we have that new object ready to go. The transcribe speech will also wrap in a try catch just in case, and if we do get an error, we're going to go ahead and console error. All right, and one final tweak on the server side of things, because we are going to be accessing our server from a browser on the internet, let's also enable cross-origin requests on our server. We'll do this by setting the middleware. We'll set app.use to the CORS invocation on the CORS method. We are going to be importing this from CORS. We will import CORS from CORS. Let's go ahead and run npm install CORS in the terminal, and while we're at it, let's also import the types for CORS. We'll copy this dev command to install the types and then paste that into our terminal, and now we have the types CORS, and we'll run npm start to restart our server. All right, now that our server is started, let's run npx expo start -- web from the client directory in the terminal, and that will start up an Expo Go project for web. This might take a little while to get set up when you're first starting it up, but after that it should be much faster. So we'll wait for this to complete. All right, so now that we see that the web has been bundled, and we can go ahead and check out our app on Chrome and Safari. Let's start with Google Chrome. We can see my microphone is in use. My project is running on port 8081, and if we go to a different tab, we can see that microphone icon shuts off. So it's not just perpetually running in the background. Now for the moment of truth, let's try speech to text. Hello, I'm testing the speech to text functionality in Google Chrome. We see the loading spinner as it hits the API, and we get our speech transcribed into text from Google. Switching over to the Safari browser, we see that permissions pop up. When we click allow, we see the microphone icon come up in the tab for our app, and when we go to a different tab, when the tab unfocuses, we see that microphone permission toggle on and off for the current app. So that's working well. It's not just active in the background. Let's try the speech to text. Hello, I'm testing the speech-to-text functionality on Safari. Again, we see a loading spinner as our request hits Google's API, and we see a successful speech transcription. That brings us to the end of this speech-to-text tutorial. Thank you so much for watching. I really appreciate it. I really enjoyed making this tutorial. All of the source code that we've written today will be made available in this GitHub repo that I'll post a link to in the description of this video. If you've made it this far, feel free to add a like to the video, add a comment. Just so I know that you've made it to the end, I'd love to see a talking head and a writing hand emoji in your comment. That'd be cool. Only real ones will know. Everyone else reading the comments will be like, hey, why is everyone leaving these emojis? Anyway, subscribe to the channel, and hopefully I can make more awesome tutorials like this in the future. Again, thank you so much for watching, and have a great day.